In this video, we're going to review sex-linked traits. And so remember, these are alleles, genes that are on the X or Y chromosome. We're mainly going to be dealing with ones that are on the X chromosome and that are recessive. So remember, this is a female. She has two X chromosomes. And so if she were to inherit a recessive trait, like let's say for color blindness, from one parent, if she inherits a dominant allele from the other parent, then she's good to go. She's going to have normal vision. The only way that a female can inherit one of these recessive traits is if she receives it from both parents. And that's a little bit less likely to happen. On the other hand, a male only has that one X chromosome. And so since he only has that one X, if he gets one recessive allele, he's going to have that recessive trait. So that's why it's much more likely for a male to get a sex-linked recessive trait than a female. He only has to inherit it from one parent. And in general, the way that's going to work is that the dad is going to be the one that determines the sex of the child, because he's the one that either gives an X or a Y. And then the mom is going to be the one that really kind of determines the traits, at least for the males. So in this case, the mom gave a recessive allele, so that kid is going to have whatever recessive trait that is. All right, so again, remember, this is a male and this is a female. Now, to indicate a dominant allele, again, I'm just going to use a big letter just like I did before. And recessive is going to be a little letter. The only difference being that I put it above an X to indicate that it is a sex-linked trait. Alright, so this would be a male because they have a Y, and notice the Y does not have any letter over it because the Y does not have the same genes. And this is a male that has the dominant trait. So if this was hemophilia, for example, he would have normal blood. This male, on the other hand, has the recessive trait. He would be a hemophiliac. Alright, this would be a female because she has two X's and she is homozygous dominant. Since she has the two X's, I have two alleles for her. And it works exactly the same way as it would if she just had big H, big H. It's just, again, I'm putting them over the X to show that this is sex-linked. This would be a female who's homozygous recessive. Again, this is the only way that she can have the recessive trait. And then this would be a female that's heterozygous. And another word for heterozygous with this is a carrier, because she is carrying the recessive trait, but she doesn't actually have it. And what you should see is that this means that she can actually give it to one of her sons. Alright, so let's do a Punnett square with this and using hemophilia as an example. So here is a female, and she is a carrier for that sex-linked recessive trait. And then we have a normal male. So we set up the Punnett square exactly the same way, do the Punnett square exactly the same way, and what you'll notice is half of the offspring are going to be females and half of them are always going to be males. I have one male that's affected, and again that makes sense because males are more likely to get it, and they get it from their mother. I have half of them are unaffected, and both the mom and one of the daughters are carriers. So again, sex-linked recessive traits are mostly inherited by males, inherited from the mom, and are things like hemophilia, color blindness, muscular dystrophy. Those are all examples. Alright, and that is basically sex-linked traits.